are go. All systems on. Where is my window? Here it is. Are we live? We should be live. Twitch.tv. Let's just check, make sure I have sound. I'm just gonna say words and then... Perfect. Alright. Ooh, the Ratchet and Clank machine learning is back live. That's fun. Okay. We're just gonna spam this link around a little bit. Where are we? Announcements. What are we doing today? We're doing VIF. Okay. Yeah, screw it. I'm not going to spam this everywhere. We're just going to chill. Today we're chilling. It's been a little bit. I've been enjoying life, and today we're just chilling. It's really cold. I'm wearing layers inside, which really confuses some people from overseas who aren't used to this. Okay, so... hi, I'm Tom. I talk about code. Today, we're going to be diving back into PlayStation 2 Homebrew. We're going to be doing the magnificent refactor that's been ongoing for a little bit. Haven't really done much off stream. I've done a little bit off stream. We are gonna get something on the screen today, because right now, if I go over to my wonderful PlayStation 2 Homebrew program, if I make clean platform PS2 make, and then if I work out why this happens, that was on my list of things to do off camera and I didn't do it. So what do I have to do? Platform. For some reason, building Lua is just really stupid. It just doesn't really work. But anyway. Oh, I've got a Quake boy in chat. Good morning. Are you a programmer as well? A lot of Quake people who come into my chat, it turns out, are programmers. It's very unexpected. So now if I make no? Oh yeah, platform PS2 I've gotta fix this make file nonsense. Now if I make run, we're gonna see that I get a cool black screen. So that was a lot of work to show a black screen, but and there's a reason that it wasn't building straight away, but anyway, we get nothing. Not only do we get nothing, we start drawing the first frame. You can't quite see because I'm in the way, but we start drawing the first frame and then it halts. Like, there should be log spam. I've got trace logging enabled. We should see a lot of stuff here, and we just see nothing. So, what does this mean? What are we doing? Something's going really, really wrong here. And so what I've done, I ran this, and it's actually kind of cool. I saved this before we started. I ran this code in my simulator, and this is a Linux binary that runs and kind of implements enough PS2 SDK APIs that it can pretend to be a PlayStation 2 as far as my program's concerned. But instead of doing things like sending, memory around to different hardware components and actually drawing anything, all it does whenever we interact with PlayStation 2 hardware is just log stuff. Which is cool, because it means I get these really interesting, many thousand-line logs, over 1 million lines of log, and I can just poke through this and see what's going on, which is cool. So lots of this is my own logging, but occasionally we dip into, for example, after this buffer, this is what the DMA stuff is doing, and we actually see there's a really important DMA error. It doesn't know what one of the DMA tags is trying to do. DMA, direct memory access, we're pinging stuff around different parts of the PlayStation 2 hardware. So, let's jump in and look at the actual buffer that we're sending, right? So the goal, I found some problems in this buffer. Let's just quickly draw this picture again. It's my favorite picture to draw, right? We have the CPU. The main emotion engine CPU. And then we have, a TV somewhere at the bottom. Let's draw a cool little TV. Right, and this has like stuff on it. To get to the TV, we have to go from the CPU via the graphic synthesizer, and then that kind of eventually goes to the TV. This is a gross oversimplification. Now, this is what we've been doing so far. Now, what I'm trying to do right now is, instead of going direct to the GS, go via a hardware component called VU1, which can eventually do a lot of maths. For now, we're just going to ignore all the maths and kick it straight onto the GS. Now, actually, what we're doing is a little bit more complicated, because we're not just going... oh, lost my color. That's not the right tool. We're not just going straight to VU1, we're going via the VIF, which then sends things on to VU1 and also the graphics synthesizer, and then VU1 also send things to the graphics synthesizer. So the graphics synthesizer is like the center of our universe right now, and we're just trying to work out how to feed data to it. The problem right now happens in between here and here, right? The stuff we're sending to the VIF is incorrect, so the stuff... Well, actually, no, sorry. The stuff we're trying to send to VIF is just incorrect, because it actually... This is too simple. This is an oversimplification, because we don't actually send something directly from the CPU to the VIF. Well, we kind of do, but this happens via DMA. And the way we're actually building our DMA is incorrect. So very fundamental things to this whole process aren't happening properly, and that means that it's all falling apart. The wheels have fallen off. The wheels have fallen off the bus. This works. This I can do. This is fine. This problem. It's a very simple overview of what's going wrong right now. And the reason it's going wrong is, yeah, the fundamental data that we use to tell the DMA what to do isn't being built correctly. So let's jump over and have a look. These are the hardware docs. We're going to look at them a bit. This is the actual data that we're sending, that, you know, we're kind of handing over to the DMA controller. We're saying, hey, here's a really big buffer. Work out where it should go. So this first bit here is our DMA tag. This tells it where to throw it off to. This looks correct. I think this is all okay. Then we have VIF code, the stuff that tells the VIF what to do, and this is incorrect. And I noticed in between streams, I did some digging, I've looked at these buffers a little bit. I noticed that, if I can remember how to go up a page, we'll think about these bit patterns a little bit more. Those are the VIF codes that we actually want to send. There is this wonderful... Yeah, so these are 32 bits, right? VIF codes are 32 bits. And this happens here. So here's a data example, right? The DMA tag is 128... Well, no, sorry. This is 128 bits. The DMA tag is 64 bits. Then the VIF code comes right after it. So you'll notice, here's 64 bits for our DMA tag. Well, this whole 128 bits is our DMA tag. And this is backwards. So here's the least significant bit of theirs. Here, the least significant bit of ours is weirdly here in the middle. There are two ways to visualize data, and then I've picked a third demonstrably incorrect way. We're going to deal with that. We're just going to accept that and move on. So our DMA tag lives here, and then we will have these zeros. And every DMA tag we build is going to have these zeros here, because they're 64 bits, but they have to be 128-bit aligned. So it turns out that that's where you put your first VIF code. Now, any subsequent VIF codes, you know, they get 32-bit aligned, I guess. And they can start at any 32-bit offset, but the first one comes immediately after the DMA tag. So instead of having this here, this should be here. Now, I believe the way we're building these tags just does not support this right now. If we look at draw common, if we look at, I think, buffer, right? Draw buffer.c. If we think about DMA tag, if we think about DMA tag, start CNT, yeah. And so as soon as we build a DMA tag, we advance our head and our offset by a quad word, right? By 128 bits. So we don't want to do this anymore. We need to think about how we can support these VIF tags going immediately after a DMA tag. So if we're doing stuff with the VIF, we want to do this. If we're doing GIF tags, if we're sending stuff straight to the graphic synthesizer, so for this path, this part of the diagram, then quad word increment behavior is correct, because you don't want anything here. That's just going to get mulched. But then when we do this, we have to build these tags slightly differently. So we have two options. We can add a diverging path that's going to do something very, very different, or we can try and wrangle these two things together and probably make some code choices that we'll regret later. Dinkleman, welcome. Yes, we're doing more PS2 dev, and we're going to get stuff working today. I can feel it, because I've worked this out. I can see what we've got to do. Okay, so Where's this going? Where's this going? We call this, right? We call start CNT. And then immediately after that, we're gonna call, so if we look at draw 2D, I guess, VIF, where's our VIF tag? Where do we start building a VIF tag? Do we start building a VIF tag? Okay, I don't think we actually build a VIF tag anywhere, which is kind of funny. Common VIF, VIF code, sorry, I need to call them VIF codes, right? I can't actually remember if I did this or not. Draw VIF code. Direct start. No, okay, so we're not actually calling this anywhere, which is kind of funny. Now, again, this is just incorrect. We don't increment like this. We only increment by the size of uint32t. Okay, so that's a bit scary, but that's fine, that's fine. Okay, so, I guess we kind of need to know if we just had, no. Okay, hold on. My brain's spinning, and I think I feel it. I feel what we need to do. This is incorrect, right? And actually, let's refer more specifically to the DMA docs to be a little bit more confident before I say this for absolute certain, but I'm pretty sure I feel what's going to happen. But basically, DMA tags are 128-bit aligned, but the thing that comes after a DMA tag is not necessarily 128-bit aligned, so this is incorrect, okay? GIF tags are 128-bit aligned. So when we start a GIF tag, we should ensure that we have this alignment, but we shouldn't rely on the DMA tag to do that alignment, especially when we're intermixing VIF and GIF. We're going to end up in situations where, well, VIF tags don't care about this 128-bit alignment. They might dump us halfway through a quad word, and if we then just start a GIF tag immediately after, it'll be incorrect. So we need to be very, very careful about what this data is. Now, there's something else that's interesting here, and that is that we have a VIF tag that then sends data to the GIF. So do the GIF tags have to be 128-bit aligned? That we'll have to experiment with, and I don't think there's a clear answer. I think I'll just have to try both options. If that's a few too many words, hopefully we'll get some good code demonstrating it soon. But basically, this is incorrect. But I'm gonna clarify that before I'm 100% confident. So where are we? This is the DMA stuff. Interleave mode, destination chain, source chain normal, align. I really want alignment. Should be aligned to this boundary. So your data transfer has to start at a quad word boundary. That's important. Transfer address is specified. Physical address is not converted by the TLB. Bus snooping is not performed. 8 quad word slices. Transfer of 1 slice is completed. The channel is used. Blah blah blah. Chain mode is available. This performs processing. Blah blah blah. That's excellent. It's really cool. The DMA controller is really, really cool. It's going to be fun to do some optimization with it. Synchronization, we don't really care about. Okay, DMA channels, these are important, but not right now. Physical transfer, logical transfer. Cycle stealing, normal mode. Okay, burst channel, yep, this is just about synchronization. Source chain, DMA transfer from memory. First, DMAC transfers the data of the size specified. Yep, transfer processing. A series of transfers is enabled by clearing. Transfer 8 quad word slices. Transfer of the tag, whether to transfer the tag itself with the data or not can be specified. That's interesting. The tag itself is transferred before the DMA transfer. 17 quad words. But yeah, I don't think it may not actually say the tag. The format allow. The format ID is the field. Okay. So I don't know if it actually specifies that this has to be quad word aligned, which is interesting, but I'm pretty sure it does. All their examples have it quad word aligned. I really doubt, like, it doesn't say, your DMA tag has to start at a quad word boundary, but I'm pretty sure it does. Okay, we're just going to assume it does. So likewise, right, we're kind of doing this backwards, right? We're forcing this quad word alignment after we write the thing, but really now we're mixing in something that isn't quad word aligned. So we need to say while c head mod, what is it? What is head? Head is in bytes, right? Quad word size. Head is in bytes. Yeah? Mod. So 128 bits is it's 16 bytes. 4 times 4, 16, yeah. Not equal to 0. C head plus equals 1. Right, so we're just going to ensure we're aligned to this quad word boundary. And then we need the offset to plus equals 1. Okay. And we should probably write a function for this, honestly, because it's going to happen so often. So maybe let's go... And let's give it maybe unsigned int. And we'll do just what we did before. While c head mod b is not 0. There's a smarter way to do this, but we'll do it the dumb way for now. Head plus equals 1, c offset plus equals 1. Command buffer align head. Excellent. You know, we should do a length check as well, but we won't for now because we're a bit silly and we're playing loose. Okay, where are we? Command buffer align head C 16. Cool. Now we actually what are we doing? Size of uint 64. Now we just progress the head by the actual size of the thing that we're sending, which makes a lot more sense. That's a lot better. That's a lot cleaner. Likewise, yeah, we're going to have the same thing now. Size of uint 64t. And, you know, maybe we should have a size of DMA tag. Maybe that's better, but maybe not. I don't know. But this feels good. Align head. Update last tag is fine. Direct start. So again, like this doesn't, well, this is aligned to uint32, but we'll assume uint32 alignment, okay? We'll assume that at least. We shouldn't, but we will for now, because we've been fine assuming quad word alignment too. We probably actually need this here more. We're going to copy the function. We're going to duplicate the function. Because it probably should only live in one of these places eventually. So we'll do the silly thing for now. Okay, so when we do a GIF tag, the first thing we do is command buffer align head S16. So this means, this is equivalent to what we were doing before, just it's more complicated, but it supports more kinds of things. This is what we want. Okay, so when we start a GIF tag, now, if we start a GIF tag 128-bit aligned or quad word aligned, we can probably just assume that all of the tags that come after are okay. So let's be a little bit fast and loose, and let's say that, yeah, if we start 128-bit aligned, we actually don't need to worry about anything else. The rest of the GIF tag will be fine. Carloid. What am I fixing now? Isn't it easier to use memoline or heap data? Okay, let's pop this out for a sec, because this is an interesting comment. So, What am I fixing now? So what I'm fixing now is my bad draw buffer building code, memline or heap data. So the actual data we're writing to is aligned to quad words, right? Just by necessity. But within that buffer, we have different things that have different alignments, right? DMA tags have to be quad word aligned. GIF tags have to be quad word aligned. VIF codes do not have to be quad word aligned. So suddenly it becomes kind of important. When we start a new DMA tag, we need to make sure that we're aligned to the right place. When we start a GIF tag, we need to make sure that we're aligned to the right place, I think, but also maybe not. So that's that's kind of tricky. But we can maybe hack that if that's not the case. That's actually going to be... Well, we'll see what happens. We'll see what happens. I'm going to build this and I'm going to run this and I'm going to see how badly it blows up. But at least the VIF code should be in the right place now. Now what happened there? Oh, I need to... Let's export platform PS2 and... Okay, here we go. Oh yeah, I should probably rerun nvim with these. Cool, so... make. That's very funny. Binary car. Okay. Let's just make this an unsigned. Unsigned int. Unsigned. What's the type? What's it called? What's the type that can hold a... Well, I guess size of, right? Size t, sorry. Can hold a pointer. So let's... Can we just cast it? Can we just interpret this as a integer type? Actually, I guess C offset, right? Because that's already just a size. Except that's also not quite... Is it? Is that okay? What went wrong? What went wrong here? VIF code incompatible type. That is okay. That's just a warning. Set uint 16 char. That is totally fine. Control reaches end of non-void function. That's fine. We can fix that later. Align head. All right. Yeah, we duplicated this function. So and again, this is only we've duplicated the static just because perfect. Just because it makes sense. Oh, that's not what I wanted, is it? That's very... I hate when I close the wrong window and then I'm just left with my quick fix. Anyway, let's see what happens here. Still hangs on the first frame. So this is good, right? This is good. This gives us something to go on. Now, we're going to actually clean up all of this. And we're going to build it... let's go... Let's go to our Lua directory, which for some reason doesn't get cleaned up. Oh, you know, I think I actually just worked out why my make clean Lua doesn't work. Oh no, we use the right make file. Okay, annoying. Cricket, thank you. Always respect the Parko, very important, very important. Anakim Luke, welcome. Hope everyone's going well. I think I'm streaming at an okay time for North and South America at the moment, so that's kind of cool. Always good to see my Brazilian friends stopping by. Okay, so one of the cool things I showed earlier in the stream, I can build this for Linux, right? This has a Linux build as well. I have a Linux simulator. So now I can make run sim and it will spam a bunch of stuff to my console instead of actually running a PlayStation 2 emulator. And the cool thing about this is it lets me just dump this out to a file and then look through what's actually happening without having to start up an emulator every time, without having emulator log spam involved, and I can see what's going on. So, this looks really wrong. This looks really wrong because this is not in the right place. This should not be here. This should be, this is a very mangled GIF tag. The VIF tag, this looks like it's in the right place. That's cool. So this is the least significant bit. Which font and theme is this? This is Groovebox, I'm pretty sure. And the font is Deja Vu Sans Mono. I should know off the top of my head, but apparently I don't. I don't know why I landed on Deja Vu Sans Mono, but it looks pretty nice. I'm happy with it. I'm very happy with it. Okay. What's going on? So let's double check that this VIF code is correct. And let's just look at these docs again, right? So let's find VIF code. Let's find that cool document. Where are we? We're going down. Yeah, this one. So least significant bit, right? So this is the worst dump format ever. I need to flip these bits around so it's easier. So we expect the DMA tag to be in the bottom, and it is. That looks right because the DMA tag. Yeah, that looks right. And then we have VIF code 0, which 1, 2, 3, 4, 5, 6, 7, 8. I don't know why something is leaking over here. Oh, that's the first. That's the first word of GIF tag, right? This whole GIF tag is 1. No, it's. I feel like this GIF tag is. This should be the last. This should be this E should be over here, right? So it's. That's one word out, but then why is this here? Why is this in? Why is this so early? This should look like this. This should go 100000001, and then I think it just should be 00000E, or maybe this one should be here. But like, oh god, this is stressing me out. And by the way, this is NeoVim. I was using just Vim for a while. It's all very vanilla anyway, but I do really like NeoVim. I like scripting stuff in Lua. Like my status line, I wrote myself in Lua. And I really should do some streams where I just hack on NeoVim, because it's a really cool platform to write random hacky scripts for. Okay, what's going on? What is happening? So our alignment is broken. Why is our alignment broken? Because I broke it. Because I wrote this jank buffer. No, that's the wrong buffer. I need draw buffer. I wrote this jank function that doesn't align properly. Really jank function. I really need unit tests. Okay, what happens if I go back to kicking, let's go to common.c frame, and let's go back to kicking to the GIF. Which for some reason rebuilds Lua. I don't know, it's a really slow build. And let's at least see what happens here. Load file. Cool. And this looks the same. This looks very much the same. 5, 1. 1, 2, 3, 4, 5, 6, 7, 8. This is. Okay, hold on. Let me reconfigure this. That's still wrong though. That still isn't right. That's still a. Damn! I've broken something really odd, something really strange, and something really annoying to fix. Because we're not even gonna have VIF. No, we shouldn't start a. Oh, but we do anyway. We can't just go back. We can't just pretend VIF codes don't exist. We're starting them. It's all there. It's there. So we need to change main.lua. We need to change what we're actually running. And actually, I think I can do that at the command line. Dist test. No, hold on. What is it? Test. Okay, there we go. I should be able to do this. What is it? Script. E.g. let's do a simple one. Let's just do our normal rectangle test and see what this looks like. Okay, here we go. This is better. I always forget that when I run this outside of the PS2 world, I can actually give it a command line argument. Git bisect. I don't need git bisect because I know exactly what I changed. However, I just don't know why it's doing this. Because this is our DMA tag, and before we just had zeros here, and we expect that we still should have zeros here now. So let's think about what this example is actually doing. Let's look at this rectangle example, right? It starts a frame, dumps some stuff in, and it ends a frame. That's it. So let's go into our well, let's quit this. Let's go back up a directory level because otherwise we're going to end up editing the wrong files. Common.c. Let's common.c. Thank you. So frame start a frame, start a CNT, put a VIF code in, which we actually don't want to do for now. Let's leave the VIF code there, I guess, even though it's silly. And let's continue to kick via the VIF, I guess, even though it's silly. So start a VIF code. Okay, so if we start CNT, the first thing we do is align the head, which should do nothing because the head, it should be 16-bit. It should be quad word aligned already, 16-byte aligned. Set this stuff, and then we advance by 8. Then we do a VIF code. We don't care about alignment, we just dump it in wherever, and we advance by 1. So the head, by the way, thank you for following Amoeba God. That's a fantastic name. Welcome to the PlayStation 2 homebrew madness. So our head will now be at 9. Or the offset increases by 9, by 1, by 4. So 8, 4, so 12. 12 out of 16. So we're like 3/4 of the way through a quad word. And then we go direct, we do all this stuff. Then we pack a GIF tag in directly because we're still using PS2 SDK draw functions to clear the screen instead of using my own stuff. So what we need to do first is we need to use command buffer align head on our draw buffer, and we need to 16 byte align it. Okay, that's good. Let's go back to our I don't know, why does this build Lua every single time? I need to fix my jank make files. Okay. Now, hopefully this has reloaded the file. This looks good. Okay, this is a GIF tag. This is a properly aligned GIF tag. This looks good. So the only problem was that I was intermixing 2 ways of building these buffers, and I wasn't really considering that. So the rest of this looks okay. So let's manually read this GIF tag, okay? So we have this DMA transfer. Well, let's read this whole buffer. We have what should be a VIF code, and I haven't really verified that these VIF codes are correct, so let's actually take a moment to do that. Let's scroll the correct way. What are we putting? We're putting this not offsets, double buffer, data pointer, mark. What VIF code are we doing? Transfers. Direct. Transfers data to the GAF. So 10100000, and this goes in the upper bits. So this is the immediate size. So 5C, this is subpacket length. The subpacket length is 1 plus immediate times 4. But this tells us the amount of data in 128-bit units. One plus immediate times 4. Times 4. So it's like we're saying in words, but then those words get multiplied by 4. Right? Divided by 4. So I don't know if we're dividing by 4 properly, but 5C is 92. Okay, so here we have a GIF tag. This is okay. So we expect 92 lines. 1, 2, 3, 4, 5. So if we go down until you can't see my line number because my face slightly covers it, it's just here. That's 43. When this says 9, then it's happy days. Okay, 92. That is actually the entire transfer. So that's the correct, that feels like the correct number. Oh no, yeah, no, that's the correct number, right? Yeah, that's the number of quad words. It might be off by 1. That's the only thing. It might be off by 1. But these GIF tags look okay. 1, 2. So when I'm looking at these GIF tags, by the way, when this is E, this kind of says what registers we're setting. So this is like we're setting one register one time, and we're setting the E register, which means that the lower quad word is just the register that we're actually setting. So in other words, I read this, I see it's E, I see we're only setting one register one time, so we're setting the registers directly. We're setting register 47 in the graphic synthesizer to this value, then we have another one, we're setting two registers this time, so we set register 1A to 0 and 1B to 04, then we do another two registers, this is prim and something else, and then we set 55, 24 times 24? No, two registers 2 times. Two registers 2. 1, 2. I don't know if that's... Oh no, that is maybe right. Maybe that's not right. I'm suspicious of this. Anyway, it's probably fine. We set 1A back, because this is all the PS2 SDK code, so that's... This should be clearing the screen. I don't think there's enough data here to clear the screen. Maybe this is actually broken now. Maybe we're not advancing the head properly after this. Is that possible? Because 24. 2 loops. 1, 2, 4. I can't remember what this bit means. 5151. And then we have a bunch of other stuff. 9. We set 2 registers at once. Oh no, sorry. So this is the screen clearing, I guess. Have I lost alignment? I might have lost alignment because I don't really see. And then we come back. Where's my GIF tag for drawing the rectangle? E1. This is our last GIF tag. We told the GIF that we're done. I don't really see another GIF tag in here, but if it jumps out correctly at the end, then it might be okay. Okay, that's a bit scary. That's a little scary. And then when we actually send it through... Yeah, okay, well look, let's see if we can do it. Now what's interesting is it doesn't look like we actually went into, because when I make clean, it's clean all. Okay, now if I make, it will build and work properly. This is what I've been stuck on every now and then, where Lua won't compile properly or compiles for the wrong architecture. So what happens if I run this? What happens if I run this? We still get a blank screen. We still hang on the first frame. So this buffer is just really balked. But that's okay. We know that the buffer's balked. We know that this buffer is not working. So let's go back and let's just have a little think, because is that DMA tag? Then this is our 1, 2, 3, 4, 5, 6, 7, 8. This is our VIF code. Oh, whoa. Whoa. Let's actually use our brains here. This is our DMA tag. So 5C is correct. We know our DMA tag works. We know our DMA tag says the right number of quad words. We've done this. This is our VIF code. This is what we don't know. So let's double check. Let's go back to this. So the first 4 bytes. Sorry, the first 2 bytes. My mistake. The first 4 nibbles. This is the immediate size. Now this is a big number, right? This, in fact, is too big of a number. 5C7. This is a big number. This is way too big of a number. Oh, excuse me. This is very odd. I don't know where this number has quite come from, but we're obviously not calculating our VIF code immediate size correctly, because this should be in quad words. This should be like the same number, right? Or the same number minus 1. So that's good. That gives us something to look at. And then this command, so the top 4 bits are 0101. So the top bit should be set. So this is also not correct, right? Because this should be 101 is, so hold on, so 1, 2, 3, 4, 5, 6, 7. So the top 7 bits. Oh, no, hold on. The top bit isn't set, because we're not generating an interrupt. So 0101, that is 5. This is correct. Okay, crisis averted. Crisis averted. So we're making progress here, okay? We're making progress. I can feel it. I can feel it. It's coming together. We just need to look at the code that generates VIF code. We just need to look at the code that ends a VIF code. VIF code direct. Do we ever end our VIF code? Hold on. VIF code direct, VIF code no. Do we ever end our VIF code? Yeah, VIF code end. Here we go. Okay. So if we don't have a VIF code active, we do nothing. That's good. Packet length, yes. Now, if we only, now this is also a problem, right? If our VIF code length, we no longer advance by a quad word, right? If our packet length is size of uint 32t, so we've resized basically if we've just opened a GIF tag and then tried to close it straight away, nothing happened. Rewind it, scrub it from the world. If we're sending stuff directly to the GIF, we divide our packet length by quad word size, so we get the number of quad words, and then if that's not, yeah, and then we update the immediate to the quad word count -1. So that does actually look correct. That does look correct. Let's trace again here. Let's say up VIF code update im. Let's log all the numbers. So let's log packet len. Actually no, so let's do it. Let's do this. Let's say QWC -1. Okay. Make clean all, and then we're gonna make sim. Ah, yes. Sorry, we have another wonderful bot. Now, I think I can delete this, but I can never remember how. I can definitely, like, remove them. Cool. Alright, they're gone. They're gone. Thank you, Dinkelman, for noticing. They're very sneaky, these bots, you know, it's hard to know. It's really tough. Really tough sometimes. Okay, so, I mean, this is different again. You know, sometimes you add a log message and then just your code changes. It's really good. End VIF code, rewinding VIF code end. Okay, now this isn't good because we somehow have detected that our VIF code is empty, that our VIF packet is empty. So that's not good. That's because I used a single equals. This is like the classic coding mistake, and I love languages like Rust will be like, hey, whoa, right? Because I think in C, like A equals B evaluates to the value, is a value equal to B. But in sensible languages, it's like unit, right? It may have a value, but it's an invalid value to use in a comparison, which is really cool. We need to rebuild. And for some reason that means rebuilding Linux because my make files are a freaking mess. Okay, now we're gonna go back into foo. Here we go. Now we can see somehow that our quad word count is large. And this is funny. This is why it didn't divide by 4, because we're subtracting by 1. We're subtracting 1. So that's good. That's kind of good. That kind of makes sense. Okay, so QWC divided by quad word size. So why is packet length divided by... Why are these the same? How has this happened? I'm going to run to the bathroom while I ponder this, right? But packet length and QWC... hold on, sorry. I forgot where this lived. These should not be, like, the same number. This is... Something weird has happened. I've done something very wrong. And I will be back with all the answers very shortly. Okay, I'm really confused. I'm really confused, but I just had, whoa. I just had a really good chat message. Okay, and this makes it all worthwhile. You have your best ideas when you're on the throne, and I wish this was true right now. I really do. I really, really do. So, somehow, we initialize this variable called QWC, right? And we make it packet length divided by 16. Because QW size is 16. I don't know where this is defined, but I define it and it's 16. It's somewhere like super standard, right? Draw.h maybe. QW size, okay? It's 4 units. Anyway, we're dividing by something, right? Unless this is where did this go? QWC. There are so many variables in here called QWC. That was the wrong thing to search for. VIF code. VIF code end. Okay. Divided by, but somehow these things are the same, which is really silly, right? Because I know this isn't 1. Can I just like what's going on here? What is happening? And then we increment it by 1, but what's going on? What has happened? Packet len. Yeah. That's really crazy. I'm just really confused and concerned. I'm really confused and concerned. Man. Anyone in chat have any cool, just while I'm, working on something kind of mindless and silly, anyone in chat have any cool projects on the go right now? I love to hear about them. I love to hear what people are doing. Okay. It worked that time. That's exactly the number I wanted to see, 5B, because we have 5C, we have 5B. I think this should be like 1 smaller, maybe? Maybe? This is sending 1472. Okay, let's try this. Let's just run it on the PS2 and see what happens. Because yeah, I've been doing a bit of stuff on the side. I've been playing with Bevy, so I've been doing some Rust GameDev, which is cool, and I would love to do some of that on stream. Okay, still no life, but that's better. That's better. We're making progress. But yeah, like Bevy's been really fun. I've got some fun stuff I want to do in Bevy, and I've got since I went to the Rust meetup the other week, I've got some cool ideas. Got some really cool ideas. Okay, Dinkelman is way overdue for a new project. Try Bevy. It's fun if you want to learn some Rust. It's cool. It's cool. Configuring LF, ditching Ranger. What are LF and Ranger? Maybe I should know. They sound like Linux command line tools or something. Okay, so the next thing to be concerned about are these GIF tags. Because like, what's this? What's going on here? What's going on here? Because this is override. This is setting the like prim override thing. Back 47. What's 47? 47 is not sure, but this looks like my drawing code, right? So 6. We're setting 1, 2, 3, 4, 5, 6 with C loops. So that would be hold on, I can do that maths. So we're setting 6 things, we're doing it C times, which is 10, 11, which is 12. So 6 times 12 is 72. So 72 lines? Is that right? 72, 73. Off by 1 is okay, and then we finish. So the only thing I'm left to be concerned about, the only thing I'm left feeling weird about is this, because this just isn't enough data in this GIF tag. Ranges of Vim-based file manager. That's kind of cool. Yeah, TUI file managers. That's nice, because what does that offer you that just like LSing around doesn't? Right? I like LSing around. I like using Bash or like ZSH. Do I need a different view of my files? Am I missing something not having a fancy file manager? So the other question is, like, is this 2 and then a flag, or is there something else going on here? Please let me know, by the way, if you can hear the tradies in the background. They're like working on the eaves. There's some power tools going. If it's too annoying, I might have to cut the stream. But yeah, just let me know. Let me know what you can hear. Let me know how it all sounds. in window previews, that is kind of cool. It's weird. I don't think I have that many files. I don't do a lot of file management, you know? I keep things fairly organized, fairly clean, but I'm interested. I am interested in better tools for managing stuff, because some things like my photos are a bit of a nightmare. I've got like a bit of duplication and stuff that I need to deal with. I don't know. There are a few things that are like growing in size and complexity that are a bit annoying to deal with. Okay, I've got a hunch. I've got a hunch here. Because normally, like why... Okay, I need to look. I need to go back because I've kind of forgotten what this bit means. We need to find the GIF tag docs, and it's going to be really quick. We just need to look. Data format, GIF tag. Okay, here we go. So loop, yeah. So it's one of these. It's in the 1, 2, 3, 4, 5, 6. Where does it fall? Where does it fall? 5, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So it's the last. Oh, it's not the last byte, but it's the last byte of. It's this. It's this. 8, 9, 10, 11, 12, 13, 14. Yeah. So it's this. It's flag. This is 1 bit, and then this is 9. 58, 59, 60, 61, 62, 63. So it's prim. So this is 3 bit, 60, 61, 62, 63. So this is 4 bits. This is 2 bits. So that's okay. So that's the top 6 bits, which is enough. So 4. So this means there's a 1, 1, 0, right? No, 01, reg list mode. Yeah, because 4 is 0100, but we don't care about the last 2. So 01. So this is 001001, 0010, 0010, 01. 2 image mode. 2 reg list mode. And then it has this. Okay, that is actually correct. That is actually correct. Because these are packed more tightly than when I'm in packed mode. Confusingly, packed mode is less tightly packed than reglist mode. Why is it like this? I don't know. You'd have to ask. You'd have to ask Sony in the year 1999. Okay, so this is okay. This is okay, but this still doesn't look right. But it's okay. So it's possible that this is like off by 1, and I'm just going to try something really silly, which is subtracting 2 instead of 1, and we're going to rebuild and run it and see what happens. And it's worth a shot, even though we still hang on the first frame. Let me just like move this across maybe so people can see. We start the first frame and then nothing happens. It dies. Cool. So what else can we try? What else can we try? Well, there is this other problem. Where if we look, once we submit this, for some, this is actually probably the problem, right? I've done all this other buffer stuff and that looks good now, but this is huge, right? If we look at our DMA simulator, if we have a DMA tag with an unknown type, we throw this error. And we should only ever see DMA CNT. We should only ever see, and we don't do anything fancy here, right? But we should always see this log line saying that the channel, whatever it's just syncing a bunch of data to the channel. But instead, we get this error saying the DMA type is unsupported. So if we go back and let's do our friend, let's clean all, and let's rebuild this for just the simulator. Let's get a fresh dump because it's good to keep your dumps up to date. That way you're talking about the right thing. That way you're talking about the right thing. In this case, I'm not. So let's just how do I do it? No, that's right. That's the opposite of what I wanted. There we go, that's what I want. Oh, except that will just run forever. Oops, I accidentally made a very big file. That's okay, that's probably only like, what, 9 million lines? That's fine, that's fine. So we don't see any of the, we do see this stuff dumped out still? Maybe that's fine, I don't know. Oh, because, hold on, I'm being silly. I wanna, what is it, script, eg rect.lua. We want to reload this. I still don't know if this is right, but whatever, that's fine, that's fine. That's okay. This does look correct. Read verts, draw 3D. I don't know why we're calling it to draw 3D here still, but anyway. Let's just say it's okay. Let's pretend it's fine. Size 9.0. That's good. So this all looks okay. This all looks okay. This all looks fine. It would be nice if this ran the correct script. What does runsim do? It just goes to... Is there a way to pass arguments? There must be, right? I must be able to pass arguments through in a makefile. No? Maybe you can't do that. Let's just do this the stupid way for now then. Script eg rect. Yeah, okay, this is better. This is a little bit more manageable. 2E. Now here we've got this random little thing that, oh no, that's fine, that's fine. We're setting 6, we're setting 1, and then we do this in packed mode, which is good. Okay, this is a little bit more manageable. This is a little bit simpler. Kick VIF buffer, update size 21, 1517. This is still what we want to see. And when we run it, we still get this unsupported DMA type, which is weird because this DMA tag looks okay. Right, so chain mode, QWC, ID flag. So the quad word count is good, and then, so 1, 2, 3, 4, 5, 6, 7, 8. This looks good. The top bit, we need to go up, maybe. Source chain, destination chain, source chain tag, QWC. Yes, okay, this is it. PC ID 1, 2, 3, 4. So 0, 1. This is, again, this looks good. So then why does this not 1, 2, 3, 4, 5, 6, 7, 8? Yeah, this top 1, 2, 3. This top nibble should be 1 because IRQ is 0. We're not requesting an interrupt. The ID is 1. Somehow when this gets passed through, it seems to get lost. And this could be a problem with my code. Like, let me just double check my VDMA is parsing these correctly, because that's kind of funny. Type. Technically speaking, this type should only be masked with 7 because the top bit is something else. But yeah, that sounds okay. Let's maybe print the DMA tag. 08X. O4X. Oops. And type equals. Okay. T0 add a QWC type. We'll just dump some more stuff out to the terminal. Again, recompiling Lua because I like wasting time. Make run sim. Mr. Love Pickle, thank you for following. That's a really cool name. And again, as I said before, let me know if the power tool's allowed. Okay, now I see what's happened. I see what's going on. This is good, this is good. Yeah, thank you, Anakin Luke. My microphone is actually pretty good. I have to be like this close to it for it to pick me up at all. So it is unlikely that these power tools are going to get in, but it's good to see. Okay, so here's the good news. Well, here's the bad news. Our DMA tags seem a bit broken, right? Because we're picking this up as a DMA tag, which makes no sense at all. This, beautiful. This is our lovely warm DMA tag. This is what we want to see. And actually, I haven't got enough bits here to show a full DMA tag, but that's okay. Our address is... That's fine, yeah, because we don't have an address for this. Now, we appear to be one quad word short. This VIF code's thrown something off in our calculation, because the next DMA tag we try to parse is down here, is this one. Now, this could be a problem with my logic, but I'm not sure if it is. It depends how... Like, I suspect that this is wrong, because if we count 17, hex 17, which is 16 plus 7, which is 23. 1, 2, 3, blah, 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 blah. 23. But is it 23? 1, 2... We can read this. If we go and look at how CNT works, read the succeeding queue. Transfer the 23... 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, it's a problem in my simulator. HB times 16 plus 8. Why is this QWC plus 8? Why is this plus 8? Because... I don't know why I've done this. What if I do this? Okay, so we're fixing a bug in my simulator, right? But one that's gonna really make a big difference to how I can do this. Cool, yeah, okay, this is right now. But now if we look at these channel IDs, right? There's this cool table. The channel we should send this to channel 1, not channel 2. We should send this to channel 1, not channel 2. Draw kick VIF. Send channel, DMA channel VIF1. DMA channel VIF1. Let's pop over into PS2 SDK code for a second. Oops. VIF1. Oh, right, it's here, sorry. The tags, I always forget that that's gonna add some garbage. So, it's kind of weird, right? It's kind of weird. It's kind of like we're still calling kick GIF somehow. And we can see it's never called. Cause like we can see, right? We can see it's never called. We can verify this. We can statically verify. I mean, if we go over to kick VIF buffer, right? We're definitely calling this. So why are we, let's 1. We're sending to channel 1. This is the other thing. Channel. We're sending the channel. We're doing it. It's that one left shift by the channel, which is kind of weird. Because these are still, oh yeah, no, yeah, it's a bit in a thing. It's a bit in a thing. Is it an AT20? Yeah, it's an AT2020. So this didn't look like words. So is it an at 2020? What was at 2020? Yeah, AT2020, really good mic. Sounds really nice. Highly recommend. Big fan of it. It's lasted me for 10 years and it's still going strong. Still going strong. So we're really in the weeds now. We're really in the weeds. And we're in this weird thing where it's like I've got this simulator that I'm pretty sure is right, but I don't want to debug my simulator if I can avoid it, you know? We're definitely sending something weird here though, right? Like how is this getting in? How is the wrong number coming through here? It just does not make sense to me at all. Because we get a channel in and we print the channel out. We print out the name and the number, right? When our VDMA runs, we'll send it to channel GIF. How does it get a 2? How does it get a 2? Because I call send chain with, this isn't 2. This just is not 2. To VIF and not GIF. Okay, we're gonna rebuild and we're gonna run this. Could use a debugger to step through it. This is true. This is true. And you know, I guess one of the reasons that I haven't really done that as much is I'm still kind of in PS2 mode. And because it just feels... Okay, there we go. I just had to use a constant instead of this thing. Okay. Now let's make it. Now let's run it. And let's see what happens. I don't know why that was misbehaving like that. Somehow that define is just being jank. And we still halt on the frame, but at least we have slightly more confidence that this is going through to the right place now. Now, let's try something else. Let's go PCSX2 dist what's it called? P2G. Yeah, okay. We need to run it from this folder. No. Yeah. Shell PWD. This is really one of these weird, silly things, I think. With just the path thing. PWD. Oops. Whoa. For some reason, you have to give it a full path, otherwise it complains. And I don't know why this is. Debugger, I think. Yeah. So this is cool. This is something I learned about recently. You can run PCSX2 and break it at the entry point, which is very useful for debugging. Very, very useful. You don't have to like run to pause it at the perfect moment. Now, let's see if we can actually find our functions. Draw, disable tests. These are all internal things. Draw, frame end, frame end. Oh, we can actually find these. Draw, frame, end. We can filter, thankfully. So let's put a breakpoint here and let's see when we get to frame end. Ah, hold on. I didn't read, I didn't think, I didn't engage my brain, because we freeze after we begin the frame, right? We freeze like immediately. So hold on. Hold on. It's in main, right? Okay, let's see if this is gonna behave a little differently now. And it does. We actually get to the end of the frame and then it hangs. So let's go back and undo some of the jank we did because I wasn't really paying attention. VIF code end. And hopefully, okay, we're still not there, but we're making progress. We're making inroads. Things are happening. And yeah, so I'm gonna, where are we? This. We've attempted to render one frame. We've passed something somewhere, and I'm not sure where. And it's kind of frustrating that I don't really have tools that are going to be like, yeah, here's what went. You know, I can't really poke the DMA as far as I know. So we have to be a little bit crafty in how we work this out. But let's now break at frame end. And now we actually get here, right? So what's going on? What's going on? We load some things. Where are we making calls? We don't get names resolved when we jump and link. What do we jump and link to in this function? I can't put this in the background because it'll die. So what goes on? What's happening here? 0 not load some stuff from a structure. Where do we jump to? If I step into this, what is this? Printf. Excellent. Excellent. If I step into this, what is it? Draw finish. Okay. So that's okay. That's okay. We load some constants. Now we jump into another thing. This is where we kick to the VIF, and this is where we hang. So why do we hang when we kick to the VIF? Well, probably because something is built incorrectly. Something. Let me redo that, right? Let me just redo that and actually draw kick VIF. Let me see if I can pinpoint the exact moment we die. So we load. It'll have to be one of these function calls, right? So we call printf, of course. We call command buffer update last tag loop. That's fine. We call. Obviously, it's going to be in DMA chain send. NCNT. This is all my housekeeping. Draw DMA in. All just housekeeping. Now we're probably going to call print again. Excellent. Print buffer. This does a bunch of garbage. DMA channel send chain. This is where we're going to hang, right? This is where we're going to hang. And it's going to be... Whoa. So we call sync DK. This is going to be surely where we hang, right? No? So we get a lot of the way through this. We return. And then the next function we call. So if I restart this, we'll see what that is, hopefully. If I run, wait fast. So the draw never actually goes through. So we kick data somewhere. I suspect it hits the VIF, but maybe never gets to the GIF. That's good though, that's really good. So at least we know that stuff's getting kicked around. Now, my question is, right, does the GIF tag, is it meant to start here rather than here? Does anyone have an example of doing this? Is there must be in PS2 SDK, right? There must be sorry, not in EE, it'll be in samples. No, it'll be in EE. It'll be in libvux maybe. This is all like mathsy stuff. Okay, let's see if the VIF codes, I guess, are defined somewhere, right? RNI. Common include VIF register, of course, but then let's maybe see if VIF1 direct. VIF codes, where are they? VIF CMD, okay. So where's this used? Literally nowhere. No one's building VIF codes. How is this possible? How is this possible? How in this whole frickin' project is this never used? Surely someone uses a VIF CMD. No. They're defined and they're never used. Oh my god. Okay, I don't think I can fix this right now. I think I've got to find someone who understands this more than I do. But I guess for fun, right? I guess for fun. I guess for fun we could just try, right? But I need to support. So it's kind of like if we're not in a VIF code, then when we start, we can write that. We have that information. So let's go. Let's just make sure we. Whoa. Okay. Let's when we GIF. It's in buffer.c, not GIF tag new. Okay. So when we do this align, let's say if not C, not S dot. Now I need to remember how this is done. Draw.h. Draw.h. Draw state. Command buffer. VIF. So buffer VIF dot is active, not S VIF dot is active. So if we're not in a VIF code, then align. Otherwise, don't. What happens now? That still doesn't work, but it's at least a little different. At least we tried. At least we tried. All right. Holy crap. That was fun. That was fun. We did not achieve our goal. We did not achieve our goal. And that's well, we did this, okay? We didn't need to do this. That kind of already worked. But we did not do this. Let me get a nice red. Like a red for failure, you know? No, did not do this. But that's okay. Sometimes life doesn't work out, and that's okay. Man. But this has been a fun stream. I'm keen to do more of this. I'm keen to maybe do some of my Rust game dev on stream if people want to see that. That would be really cool. I have a lot of cool things I'm working on. I'd like to try and write a little programming language for my 16-bit virtual machine. And yeah, I've got a couple of fun ideas. I want to try and do some YouTube videos. I've been saying that for a while, but I've really made some cool progress because I have actually built a really rudimentary randomizer for Kingdom Hearts on the PS2, including packaging in a cutscene skip mod and having a kind of framework for writing patches that can get loaded into the game. And I think if I release these tools, people will have fun with them. But I want to do a YouTube video kind of documenting how I got there. So that's been a weird journey. Rust game dev's been fun. I'm just doing lots of bits and pieces right now. It's cool. Every new error is a step towards success. I love this. I really love this. This is a good life message. Or more errors. But success means more errors. Quite impressive. Thank you, Cricket. It's life. It is. Sometimes your code just doesn't work, and that's how it is. But yeah, awesome. This has been good fun. I'm also gonna be that guy and jump across to a new. That's what I get for trying to ask for money. No, I do want a HDMI capture device so I can get better footage out of my PS2. I think that would be really cool. So if you want to support that, I've got a little goal. There is coffee. You can buy me a Ko-Fi, a coffee. I'm never sure how to say it, but it's all here. And you'll go into the special section of my website where I thank people who have donated to me for as long as that website exists. Thank you for letting me know I was muted. I would not have picked that up. This is a new scene. I haven't used it before. But, as cringe as I feel asking for money, if you want to help me run things a little bit nicer, you are always welcome. And if that's not something you want to do, that's fine too. So, I will... Whoops. Wrong scene. Thanks everyone for tuning in. It's been a fun stream. I feel like I'm chipping away at this slowly. I'm making progress, and soon we'll have stuff happening with the vector unit. We just need to do all of the plumbing first, unfortunately. But it'll be exciting. So... This has been cool. I'll be back soon, and I will see you then.